Hey guys, so today I'm gonna do number 13 from the 10.4 homework. That's talking about using appropriate tests to determine whether or not this series converges, right? So jumping straight forward to solution, first of all, we always have to like test for the divergence test first of all. So whereby we're gonna have to look for the limit. Let's see. So in this case, you have the limit of k to infinity from k over k squared plus 6, right? So then let me zoom in. Good. So from there, and like you can pretty much, evaluate this, right? Because this goes to infinity and this goes to infinity as well. And what kind of makes this negligible, right? So this number and this number squared cause is the square of whatever number you got here. So that's, and the greater it gets to infinity, then the less it becomes till eventually you get a zero over here. So by the divergence test, since we got that the limit is zero, so we could say that this is inconclusive, right? Over here. Okay. So after this, to determine whether or not the series diverges or converges, then we could try the integral test over here, right? And so in this way, we could see whether or not, like, if it's gonna say converge or diverge. At this point, like, we're not exactly sure why. But then in this case, we're gonna have to find the relationship between this limit or this Riemann sum, as well as say this. So you got the integral from 1 to infinity from of f of x dx, whereby we could take this as our f of x. So that's gonna be all the way to, let's see, so say x over x squared plus 6 dx. Like, I just changed the variables, but it's pretty much the same thing. So we gotta find the relationship between this and this. So these two guys over here, and we can find out that one of them could converge and one of them could diverge. So in the case of convergence, for example, the value of the integral, in this case, this function over here, is not necessarily equal to the value of the series, right? Because it just shows that, at the end of the day, we're just going to converge. So, like, the value of this integral could be, 1, or it could be 2 or 10,000, whichever. But that doesn't guarantee that it's the value of this sum over here, right? So luckily we can understand that this f of x over here, one, it's continuous, two, it's positive, and three, it's non-increasing for x is greater than or equal to 1, right? So in that case, we could use the integral test over here. So basically, we gotta find the integral of x over x squared plus 6, right? And you know, doing the long and short of it, I'm just gonna skip for right now. Basically, what you're gonna get is, say, the limit as b approaches infinity of ln x squared plus 6 over 2, then ranging from b to 1, right? So that's pretty much the integral like evaluated there. I had to use u sub for, say, sorry about that, for u is equal to x squared plus 6, and then yep, and fundamental theorem of calculus too. So eventually what I'm gonna get over here is, say, let's see, so I'm gonna put these values over here, you know, completing the integral. So you got the limit as b approaches infinity, you got ln b squared plus 6 over 2 minus ln 1 squared plus 6 over 2. Then there you go. So evaluating the limit. So this b squared, because b is headed to infinity, it's gonna create not just this, but also it's gonna influence this value, because this value by the end of the day is just a constant. So this, all this is gonna, because of this, is gonna go to infinity, right? So in that case, we conclude that the integral test can be this k1 k over k squared plus 6 is divergent, because the integral of, say, 1 to infinity of x over x squared plus 6 dx is equal to infinity.